We will begin today's session, but before we begin, if some of you are joining in the sessions for the first time, I will introduce Mr. Bhupendra Singh. So, Mr. Bhupendra Singh is currently an IoT product manager at Bliss Healthcare, and he has done his graduation in electronics and communication from Sri Mata Vaishno Devi University, Jammu and Kashmir, and then PG diploma in IoT from CDAC Pune. He was with CDAC for around 3 years in its R&D team and training team and conducting various courses related to IoT and other aspects. He himself is a skilled polyglot programmer and carries rich experience in distributed ledger technologies, wireless sensor networks, edge computing net frameworks, cloud native applications, embedded Linux, tech stack, and is very keen in communicating technical results and concepts to audience with various backgrounds. He has a thorough understanding of socket programming, C, Python, Node.js, SQL, time series databases, Prometheus, Docker, Kubernetes, Grafana, and other computing frameworks and languages. He has also published 10 research papers in reputed journals and conferences. He was one of the key members from CDAC to deliver technical talks for capacity building in IoT in Northeast regions under the workshop on emerging technologies, innovation, incubation and entrepreneurship development sponsored by Ministry of Electronics and IT, Government of India during December 2018 to 2019. He is also a big supporter of FOSS, which is free and open source software, and he tries to use most of such software in his own work and training programs. So with that, I would welcome you, Mr. Bhupendra, for the morning session, and over to you.
Okay, sir. Thank you, sir. So, my voice is sir.
Yes, you're audible. Yes.
Okay, fine. So, today we are going to begin with this session. It's called IoT protocols. So, in majorly IoT protocols, if I talk about, so there are core IoT protocols like COAP, MQTT, then AMQP, and of course HTTP is one of the protocol that is from last 20-30 years industry is using. So we'll touch down all those protocols that are actually important in IoT scenario. So basically touching all the protocols in depth at implementation level is little bit difficult with the time frame that has been allocated, but I will give my best to give you the correct resources that you can refer in future for like development perspective, because theoretical is one aspect that is good to start, but what are the open source tools and technologies that you can refer in future for like developing your core IoT solutions, and how industry looks towards these HTTP COAP and plug and universal plug and play solutions in next 5 to 10 years. Of course, once we talk about IoT protocols, it means we are generally going to talk about how you are going to collect data from the devices and then route that data through gateway to cloud. Either you can talk directly from device to cloud. Basically, at a larger perspective, if you look out, there are only either two-layer architecture or three-layer architecture in IoT. So two-layer architecture, when we talk about, it means we talk about the devices that we have and they have IP capability. It means mostly we are talks about Wi-Fi modes or modes that have Ethernet capability. Other than that, IoT is getting a lot of attention with the devices having Bluetooth, low energy, Zigbee. It means low power devices, right? And I think Saras sir also discussed yesterday related to your low power devices, that how you can use those things. It means sleep modes and all, right? So there where devices like Bluetooth low energy, basically like currently I'm working in healthcare domain, so there also Bluetooth low energy is playing a very vital role for providing remote patient care, getting the data from the patient and putting this data to the doctors, and they can take the action based on those data. So there Bluetooth low energy come into the action. So Bluetooth low energy basically gives you a larger battery life around 1 month and more than that also. If you talk about theoretically, people claim it for like 10 years, 1 year, 2 years, but once you come to the actual deployment perspective, generally 1 month and 2 months is the battery life of any device. More than that, it's very difficult to get it. So where like Bluetooth low energy and all these kind of devices doesn't have IP capability, it means they need some mechanism in between to transfer the data to the cloud platform. Then there is a need of gateways, and on those gateways you require certain protocols that should transfer your data from gateway to cloud. So there your like HTTP, COAP, MQTT, AMQP, all these protocols comes in. So either you can use these protocols if your device have IP capability directly on the end device and your device will be communicating to the cloud platform, and either you can go through like Bluetooth to Bluetooth communication till gateway, and from gateway to cloud you can use these protocols for extending your data from local network to the global network. So let's see a little bit the basics of HTTP COAP and how universal plug and play, this is a very generic term, is going to make the IoT industry more closer to the deployment. Of course, because the major challenge that IoT faces is the deployment. As a development perspective, nowadays things are very accurate, very fine. Lot of development tools, technologies, even in open source are available. But once we move to the deployment, that what actually industry looks right. At academic level, we only talk about development, but in industry, we have to look for the deployment perspective, and where a lot of challenges come. So how universal plug and play? It means your IoT device is just going into their home, and automatically once this device is getting powered on, it starts sending the data to the cloud. But with these things, IoT also poses a lot of challenges like security and all, right? So that we will discuss what are those things and later. So let us get started with HTTP. So before discussing with HTTP, you might have heard the term called REST, representational state transfer, right? So it's a very generic term that is used with the protocols like HTTP, COAP, all these things, right? So HTTP, before HTTP, we must understand the REST. So REST is one important aspect which provide you the idea how one particular protocol should communicate from one place to another. It means from one device to another device, right? Either you can say in a client server architecture. So you need certain resources, you need certain methods, right? Some places you will find these terms used as resources, some places you will find these terms used as method like get, put, post and delete. For example, if I talk about an IoT scenario, you want to upload some data on the cloud, you want to delete that data if required. If required, you want to update that data, and if required, you want to get that particular data, like what is the status of the LED, what is the current temperature of the room, right? So you need certain mechanism. In REST, we say it as a resources. Like get means you want to retrieve some data from the cloud environment, you want to update some data, that is put, and if you want to create new data, then you have a post resource, and if you want to delete some data, you have a delete resource, right? So these things are mentioned inside the REST documentation that we refer. So REST is nothing but it's just a way of doing things. It's not a protocol, it's not a architecture also, right? So HTTP take the benefit of REST, right? So it has like majorly data exchange format. If I talk about, it's a JSON, JavaScript object notation, and one of the major data communication exchange format is JSON in IoT, right? So yesterday I was discussing about a little bit about dictionary, how dictionary works, right? So similar syntax JSON also follow, and reason behind that to use JSON is that it's very lightweight. It means if you are sending the data, so you are sending the data in KB, while if you will go for PDF or any other format for exchanging the data, of course your size will increase. And once I talk about IoT, so IoT it majorly take care in constrained environment. It means where your processing power is very limited on the devices, you are dealing with hardly 4 MB of PS RAM, or below that 512 KB of ROM for storing your firmwares. And then more important, bandwidth is one of the major challenges. So these things we need to take care while sending the data also. So what format we should use and what format we should not use. So that's why JSON is one of the major format that is used across the industry in IoT solution. And then coming to the HTTP version, right? So there are various versions of HTTP available, and latest one is 2.0. But still most of the browser doesn't have 2.0 support, so we are relying still with HTTP 1.1 version. And more important, HTTP everyday we deal, right? We open any web browser, www.google.com. On the top of application layer, by default your HTTP or HTTPS works, right? So if you are using S in secure mode, so it will be on the back side, it will be a socket layer that will be created, and it will be doing the your communication in a secure mode. So important aspect it what communication model it follows. Like there are various protocol like COAP, MQTT and HTTP, right? So what communication model follow? Like if you talk about MQTT, it's request response model, right? But HTTP is like MQTT is your publish subscribe model. But while we talk about HTTP and COAP, it follows request response model. It means you can request some resource from the server, and if that resource is available, it means some data that is available on the server will be sent as a response by the server to the client, right? So that is request and response model. Take a very layman example that every day we deal on our thin and thick clients like your web browser or mobile web applications. In Google Chrome, Mozilla Firefox, we put some URLs and we go for look for some resources, and if that resource is available on that particular URL, we get those resources, right? So basically it's a request and response model. So whenever we hit some URL on our browser, so we are requesting some resource from a server that is centralized place in a WAN network, right? And once that resource is available, we get that resource. For example, you can download some files. Either if you are looking for some sensor data, you will get some sensor data in IoT context, right? So that is a response. If that thing is not available, you might have seen multiple times you are getting some stated code like 403 not found. So 4.xx series codes. Then request is made from client to server and response is made from server to client. So coming into the IoT context where request comes in, right? So generally request is made from client to server. It means here what is actually going to be your client. So your client is mostly going to be your most of the time if you are looking for retrieving some information, either your mobile applications, either your web applications, right, where some browser will be there to retrieve the data. But try to understand, we will also be making requests from IoT devices for generating some data my device is generating. So I will be also posting some data, I will be some creating data on the cloud. So at that time we will be also using the a request from our IoT devices side. So that IoT device need to run this particular certain SDKs, software development kit, that that must support HTTP, right? And for HTTP the important aspect is that your IoT device must have TCP stack. Until and unless it doesn't have TCP stack, it cannot support HTTP. So in that context, your device will be doing the post operation in the backend. It means it will be creating some resource on the IoT platform, either you can say cloud. Nowadays cloud computing is less used in the industry. People have now started using IoT platforms, right, in IoT context. So response is made from server to client. So whenever you perform get request, right, get request, so generally you get a response, from server to client. So it's basically from IoT platform to the mobile applications, right? For example, you see this one example, I try to put it in the pictorial view so that things will be more clear, right? So talk about mobile, either web applications in client server architecture. So you are making a request, you want to understand what is the temperature of my room. So for that there will be some sensor put up in your room and will be having some IoT device, and those sensor will be interfaced with that IoT devices. Like for example, in this diagram I have put up Raspberry Pi that we are going to see in the last session, in the third session of the day. So whenever you are generating some data, you are posting it to the IoT platform, right? So that data is available on the server, and once any particular web application or mobile application is making a request, it is getting in a response. You can see like temperature is equal to 27 degrees centigrade, and then media type means what is the data exchange format. So here you can see applications like JSON. It means data that is coming back to the mobile applications or something, they are getting into the JSON format. So what is very important in if we are understanding HTTP protocol, so that is URL, right? URL that you see on your website, whenever you put like a HTTPS, HTTP colon forward slash www dot google.com slash some like application form, then query string, say like IIT GOA, right? So if you are interested for some application form at IIT GOA, so this way you look at URLs. So URL is nothing but generally if you talk about, so it's like uniform resource locator, right? So uniform resource locator means that resource must be available or can be located by any particular client, and uniform means this should be generic for any client. It should not be like for my mobile application link should be changed and for other mobile application link should be changed. It means it should be uniform, it should be generic for any particular application, right? And then if we have to understand how your URL looks like, for example, I have put up on the top of there http colon forward slash www.demo.thingsboard.io, so that is open source IoT platform. Colon 8080 means either you should see port number 80 or 8080. So here port number 8080 means your communication protocol is HTTP. Also from the top you can see that HTTP is written first, protocol name, and then v1 slash API slash humidity. It means there is some particular directory where my humidity data is getting stored, or you can say some path, some resource location. And then I'm looking forward to have does we have any data. It means I'm trying to query that does humidity having value 10 is available or not, right? So that is called query string when we talk about result is equal to 10. So here I have tried to elaborate it like, HTTP is what your protocol, 8080 is your port number, and port number is generally 16 digit number, and it ranges from 0 to 65535, and mostly it's, if you are talking about 0 to 1023, it is basically reserved for your internal applications. For example, like your inbuilt HTTP port will be used port number 80, right? And then for example, if you are using MQTT protocol, it will be using port number 1883. But mostly till 0 to 1023, the ports are used by for your internal services. So kernel basically allocate lot of services internally, like for example, if you are running SSH, so by default port number 2020 22 will be used for that applications, right? So port number generally ranges from 0 to 65535. So 8080 or 80 port number is dedicated for your HTTP protocol. And then result is equal to 10 is nothing but your query string. And www.demo.thingsboard.io is nothing but, if you talk about demo.thingsboard.io, it's a host name, right? So host name could be in two forms. Either it could be an IP address, either it could be have some generic name like demo.thingsboard.io. So behind that the mapping of your IP address and port number happens, and there are backend protocols that take care of all these things. And then more important, where your particular resource is located. So here if you talk about v1 slash API slash humidity, it means this is the API that we have created, that my humidity data of my sensor is going to be posted at that particular location, right? So generally if we are in an industry perspective, you talk about, so there is web application development where we have lot of available applications that we use to design our own platforms. So talk about most of the stacks, like one is mean stack, that is basically very powerful stack. Once you talk about dynamism and the speed, it so mean stack is means on the backend side you use MongoDB as a database for data storage, then Express as a web framework, that is from like Node.js, right? And then you have AngularJS for front end, and Node.js as a engine for running your application, right? So mean stack is one of the popular stack for web application development, but slowly and slowly, like Facebook and all, introduces your MERN stack nowadays. So people have now started moving from mean to MERN. In those people who love Node.js and JavaScript, so they are now mostly moving to the MERN stack for developing these REST APIs, right? So MERN stack stands for like MongoDB, Express, and then React.js. Nowadays, React.js is getting a lot of popularity in web application development, and then Node, right? So front end is using React. So React is one of the popular front end technology that is used by your Facebook. So these things that actually either you can go for the solution that is already built, but if you are very much interested to develop your own solutions, you have Java. In Java you have other frameworks like JSP and all these things you can use to develop your own platform, servlets, right? But popularity wise, if you talk about, so MERN stack and mean stack is one of the more popular stack that is used for developing these web application and creating these REST APIs. If you talk about Python for developing these APIs, we have something called Flask as a microwave framework. We have Django for developing these applications. So there are plenty of options available. Depending on the context and application need, we have to choose the stack for developing these applications. So there are a lot of methods apart from this four method, but these methods are resources basically are used by your HTTP internally to perform operations. So get is basically used for retrieving some resource state. So resource state means, if I talk about IoT perspective, so if you are like using any actuator like LED, right? Or either you can talk about your fridge that is connected with your IoT platform, either your LED bulb, right? So they will be having some state, either they will be in on state, either they will be in off state, right? If you talk about actuators. So if you had to understand that my fridge is on or my fridge is off, my LED is on or off, right? You need to check what is the current status of that. So for that you need to use get method, right, or get resource. But for example, there could be a case where you want to send some data to change that particular state. Either you want to make it 1 or 0, right? So you have to change that particular state, or either you want to create new state. Either some sensor data from your IoT devices is coming and you want to upload this data on the cloud platform. So you have post method. So post always create a new resource, right? It means the resource that is not existing, that is very important. Post method do the operation where the resources is not available. You have to create a new resource. While if there is any new resource, then you can have put method, right? So for example, if you have a sensor DST22, right, and it is having temperature and humidity. So if your temperature resource is already created, so you want to go and update that value. Temperature is equal to 22 is already there and some new value is coming. So you want to use put method, because temperature resource is already created, you have to just go and update it. So you can use put method. And then there is a delete method or resource that you can use to delete a resource. Suppose you are not no more interested that my data should lie in my database, so you can use this. So basically these are known as in web development perspective CRUD operations, right? Create, read, update and delete. So for creating you have post method, for read you have get method, and for your updation you have put method, and for delete you have delete method, right? So generally in web development terminology we say it as a CRUD operation. For CRUD operation we have these methods. So more important, while dealing with these HTTP protocol, you might be knowingly or unknowingly made with these particular status codes 2.xx series like 200, 201, 202. If anyone have done some web development using like post for testing your APIs using Postman or any other particular framework context to your HTTP or REST based applications, so you might have made these status codes. So 2.xx means if you have made some request to the server and if your request is successful, then you get a series of code like 2.xx like 200, 201. More of the time like you have made any request and you are getting a response at 200. It means your response is the request you made is successful and you are getting the correct response from the server. Then 4.xx series basically say client request problem, right? Sometimes you made the wrong URL So, or sometimes you are trying to read, reach to a particular URL where your resource is not available. So in that case, you might have met with 4.xx series status code like 403 not found, forbidden, like this kind of status code. And then 5.xx is server internal error, might be some server got shut down due to some networking problem and all. So in that cases, you will find 5.xx series status code. And then you have redirection status either error. Redirection means sometimes a place of the resource has been changed from one particular place to another place. Either you have started your communication from HTTP, but you want to move from HTTP to WebSocket, then again you need some redirection into it. So then 3.xx series code may come into the action. And then 1.xx is for connection upgrades. So generally you might have heard about a protocol called WebSocket. That is very popular protocol when it comes to the real-time applications, even in IoT, right? So where like uh, unlike your HTTP protocol, if you talk about, where there is a separate socket for request and there is a separate socket for response, it means two sockets minimum is required for doing the communication between client and server. And when I say socket, it means it's nothing but a combination of your IP address and port number, right? So generally in the backend side, you might have done certain socket programming in Python or C, so you might have understood what actually is the logical sockets. So while talking about HTTP protocol, you need two sockets. One is for like your uh, making a request and a response. But while once you deal with WebSocket protocol, there is only one socket through which your whole communication happens. It means only one TCP channel is maintained for the communication, right? So in that case, many times your WebSocket communication, if you are going to do so, initial communication start from HTTP and then your connection gets upgraded to the WebSocket. It means from HTTP and then you move to the WebSocket. In those cases, you will make this code called 1.xx, that is called information to connection upgrades. So this is very basics of your HTTP. There are a lot of RFCs are available that I will share for sure for your like readings. If you want to go more into the depth to understand like their packet size, to understand their header format. So there are a lot of RFCs. When I talk about RFC, it means these are that is maintained by IETF, Internet Engineering Task Force. So this is major standardization body that take care of the documentations related to HTTP and then COAP. So they maintain the documentation in form of RFC, request for comments, right? So that those documents I will share to go more into the internal if you want for this. And if time permits, we will see certain demos also, at least sending some data to IoT platform using these HTTP. So next, and one of the protocol that is going to be more going to be get more attention in IoT ecosystem, or you can say IoT industry in coming years. Still COAP protocol is not that much matured if you talk about development perspective in the industry. So people are still relying more on MQTT, either the HTTP, but this is one of the promising protocol once it come to the uh, constrained environment, right? So after MQTT, COAP of course is going to get a lot of attention in IoT industry. And if you have to read about more in detail in COAP, you can refer RFC 7252, right? So once you will put on Google RFC 7252, you will get the official documentation of COAP, like related to everything, how your COAP header looks like, what are the features that are available in your COAP protocol. So if I talk about very basics of COAP, so it started with the RFC 7228, right? Initially, the COAP standard was 7228, right? But what happens, like some updates went on and it got the extension to 7252. It means that if you have to read about the latest features of COAP and latest development work that you can do, so you need to refer RFC 7252. And first draft of your COAP came in 2014, right? So talking about establishment in the ecosystem, it is from last 5-6 years, right? People are working on COAP protocol, and now even most of the IoT platform started supporting COAP. You will find the extensions, you will find the SDKs, And I will show you also some open source IoT platform where you have, you know, the extensions that you can use. Either you can say some places people say it as extensions, some places you can say connectors, some places you can say plugins, right? So generally IT industry plays with you know, nothing but the jargons, and internally if you will go, then you will find that most of the terms, you know, a little bit tuning is done and they do the same task. So you some places plugins could be there, so you can look for COAP plugins, right? Either you can say COAP connectors. So most of the open source platform now started integrating COAP also, right? And ThinkSpot is one of the popular open source IoT platform that is getting a lot of attention in industry. They also support COAP and your MQTT and the REST HTTP, everything, those major protocol that we use in IoT, right? So it was basically designed for your constrained devices. It means keeping in the mind that bandwidth is at premium. We don't have the affordability to use 4 Mbps speed, 10 Mbps, because whenever we talk about IoT devices, we talk about telemetry. It means something, some data that is coming from remote locations where we don't have, you know, that control on power and everything. And mostly if you understood your REST and HTTP, it's become so easy to work with COAP because it has the same way. You have like get, put, post and delete method to, you know, to interact with the devices, to get the data, to post the data, to update the data, and to delete the data, or to delete some resources. So uh, they have lot of internal architecture. If we will be discussing, you will find that, you know, easily you can at the lowest layer you can use COAP, and on the top of that you can easily use HTTP protocol. It means proxying is also possible using COAP protocol. So if I talk about COAP in the layered perspective, so you can see there is two particular layer on the top of your transport layer. For application, there is request response sublayer and there is message sublayer called reliability, right? So reliability means this protocol runs on the top of your UDP protocol. It means, of course, connectionless protocol, right? UDP. So whenever we talk about connectionless, it means generally you forget about acknowledgement, right? But in this protocol there is a implementation of acknowledgement and non-acknowledgement. It means there are two message types that called confirmable and non-confirmable. So if you are setting the flag of confirmable message, it means you will get the acknowledgement, and if you are sending non-confirmable message, then you will not get the acknowledgement. So it is depending on your implementation, depending on your programming, you can get the acknowledgement also. And of course if you are not interested for acknowledgement and you want to make your code footprint less, so that your energy consumption at device will reduce, so of course you have that particular option also available. So reliability means it has the mechanism to get the acknowledgement, and also even though running on the top of your UDP. Second important thing, it also support your in secure communication DTLS, data ground transport layer security. And then on the top of that you have request response, get, put, post and delete method to interact with the application, like your IoT platforms are also that. So COAP sits on the top of your UDP protocol, and COAP of course is an application layer protocol. So by default, if I talk about internal structuring, it's a connectionless protocol but having option of acknowledgement. And then by default it is number 5683, where the data is so internally, if I talk about why it is good suited for your constrained environment, right? Yeah, I am also experiencing the same. There is some noise. I think someone's mic is on. Yeah, fine now. Thank you. So I hope now things are fine, right? So if I talk about features perspective. So internally, why IoT is COAP protocol is very good for IoT. So whenever you read about IoT protocols like MQTT and COAP, the major implementation side, if you will go and will bend down to the lower states, you will find its header size is very less. Like you talk about HTTP and all, they basically deal with 20 to 60 bytes of large headers. But you talk about these protocols, COAP is having fixed size of 4 byte header size. It means if you have to send 1 byte of data, sensor data, you just need to deal with 5 bytes of header. However, if other protocols you talk about HTTP and all, they carry lot of headers if they are running over HTTP and all, right? So this is one of the major benefit of using these protocol at the application layer. And they have also security, so you can easily send your data in the encrypted format. And there is something called concept of tokens. So we will discuss in coming slide how actually token looks like. So there are two things that COAP uses for its internal mechanism for matching your acknowledgement, request response and all. So there is something called message ID and there is something called token ID, right? So tokens are basically used for mapping your request and response. So there could be a case that you send a request and you get an acknowledgement and you are getting a response in a separate tray, right? In that cases, how will you able to understand that whatever request I made, I got the response? So to take care of this, basically COAP protocol, your client generates an token and server, basically attach the same token. Server do not generate any token. It duplicate the same token and attach that token with the response, so that the client should be able to understand that, okay, I made this request and I got the response of this. So we have a concept of token. And similar to the one that we talk about, we have uniform resource identifier, either you can say URLs, and then content type for sending the data and getting the data from a centralized place. Then built-in discovery, there is a method called discovery method that is available in this COAP, with which you can search easily whatever the devices are available in the network. And more important, it has 4 message types, or is called confirmable, non-confirmable, acknowledgement and reset. So when we talk about reset, it means many times it happens that you got the chunk of data but you have not got the correct data. In that case, you can send the reset message. Then you have acknowledgement, right? And then you have confirmable and non-confirmable message. Confirmable means you are requesting for acknowledgement, and non-confirmable means you are not requesting for the acknowledgement from the server. So these are 4 basic message types that are available in your COAP protocol. So if you see how this data exchange happens, because if you will go for the implementation side and you are using any particular packet tracer tools like uh, from Cisco, you have Wireshark, right? So you can use Wireshark to analyze these protocols while running on your system, client and server. So you will be meeting with these kind of IDs, like say there is a confirmable ID that is called message ID 0xAA51. You made some request from your application to get some data that is available on your server or IoT platform, and that data is sent by your IoT devices. Say pressure you want to check, right? And some sensor that is sending the pressure. So you will because I am talking about confirmable message first, so it will get an acknowledgement. So acknowledgement has the same message ID, like you can see 0xAA51, right? So for that particular confirmable message, you are getting an acknowledgement. So acknowledgement is carrying the same message ID. But there is one important aspect that need to be noticed at the client side. There is some number called token. Token is 0x14. So that token is generated by your client while making the request. But that token number is not associated with the acknowledgement, because token number had nothing to do with the acknowledgement. However, when you are getting the response in a separate tray, right after the acknowledgement, you can see there is something called confirmable ID 0xA52. It means that is new message ID, and then you are getting the data 1000 SPA, that is pressure value, right? And then with that response, you can look at the token perspective. You are having the same token that is generated at the requested, right? 0x14. This way generally your client and server map request and responses. and then there is an acknowledgement sent from client to server that I have received the value. So then again for that particular message ID, you have an acknowledgement ID similar to that. But there is also one particular concept, piggybacked response in COAP. It means your acknowledgement and data carry in the same tray, right? So in that case, your token will be associated with that message ID. So here you can see that message ID 0xA51 is okay because you are getting the acknowledgement. At the same time, you are also getting the data. So in this case, easily token number you are getting in the second tray only. But in the first perspective, you are seeing that the where acknowledgement is in different tray and your data, this actual response is in different tray. So token helps you a lot in those cases to match your request and response. So these two things that are very important to understand if you are going like internal analysis for your COAP protocol, if you are developing on your system or working with any IoT platform using COAP protocol. So this way you can easily debug your code that you are getting the response from the server or not by mapping the token ID. So this is like confirmable message has an acknowledgement while non-confirmable message has no acknowledgement. So it depends on you whether you want acknowledgement, either you don't want acknowledgement. So if I look for the architecture perspective, here there is a term called origin server, right? And then origin server is the place where actually your data is available. And with origin server, there is something called router, or you can say gateway, that is kept, right? So from gateway, and then you have endpoint client. It means your mobile applications or either your IoT device. So that is two-way communication both the sides. So you can have option that you can do the communication till your cloud platform using even gateway using COAP protocol. Either you can have an architecture using direct two-layer device if it is there, right? Like any device that is having Wi-Fi stack, then easily it can talk to the cloud because it have IP addresses, right? So here you can see that it is directly using the COAP protocol to talk to the cloud layer. However, there is the one case on the top of that third case that I want to discuss, that is called cross proxying. It means at one end from device to gateway you are using COAP protocol. However, in the other section you are using HTTP protocol. It means there is some bridging is required in between, right? So if I talk about as an open source enthusiast, there is some solution called Eclipse Ponte, right? I would recommend you to look at it. This is from like Eclipse, and Eclipse has did lot of contribution once you talk about in open source perspective, like their edge frameworks, talk about Cura, their IO fog for fog computing. So they have did tremendous contribution in IoT open source. So you can look out those solutions if you are interested more in open source. So Eclipse Ponte is very good solution that you can publish the data from MQTT, you can receive the data through COAP protocol. You can send the data from COAP, you can receive the data through MQTT protocol, and if you are sending the data from HTTP, you can receive the data using MQTT either with COAP. So three protocol bridging is very easily available using Eclipse Ponte, and it has fantastic implementation in Node.js. So easily you can write your programs even at the industrial level. So there is one more thing that is available there called observer. So this is very fantastic concept in COAP. Observer is similar to a notification based system, right? So for example, there is a case where you want to test the status of a device. So whenever that status change, you automatically want to get the notification on your system. So what you can do, you can request one additionally with a get method, you can request observe method, right? So if you will use observer method with get request, what happens when there is a change in the resource state, you will get the notification. For example, if your LED state is on for whole night, right? But in morning, automatically once whatever sensor, like for example, you have used LDR sensor, right? So automatically once your light comes in and you have deployed your solution uh, for in any parts and all for automatic controlling lighting system, right? In that case, automatically whenever your all the lights are getting switched off, it means your status is changing. So observe method, if you have specifically requested, you will get a request that now all the electricity or either you can say all the lights are switched off. So you can use that observe method, and it has implementation in Python also in Node.js. So you can program it and you can get that particular things done working in the development perspective also. So this is like very brief about COAP in architecture side and implementation side. I'll give you some hints how you can use these implementation. What are the correct places that you can refer for the implementation after finishing this. So now coming to this particular solution called UPnP, right? Universal plug and play, right? So this is very generic term that is used for like whenever you are deploying any network device that should not require any human intervention. Automatically it must connect to their access point and should start transferring the data to the cloud environment and all. So if I talk about majorly in IoT perspective, because this term is very generic used for printers and any other network device. So if I talk about IoT perspective, how you can enable this universal plug and play. You can buy any IoT device that have Wi-Fi stack for like if you are interested to use Texas, you have CC3200, very popular mode. If you want to use very less cost devices like from Espressif ESP8266 ESP32, right? These are what I believe from like when I started my journey 4 years back in IoT after my graduation. I went into more into the development side. Till graduation I was more into just understanding concept and all. There was very less development in IoT. Major development I have seen from the day when I even AWS and all were not having IoT platform properly. Even open source platforms were having very few implementation. I was writing some code in 2017, but next day that code was not working because the next day there is some change on it, right? But nowadays solutions are getting established. It will not change in a day or no, it might be 15 days 20 days takes to even from changing the version from one code to another code. So how you can implement this plug and play solution? For example, I will talk in the deployment perspective. Development is so easy. Let us take a scenario or a use case that you have an IoT device that you want to put it in someone's home to control the the internal LEDs, or you want to get the temperature data of that particular room. So what are the constraints that you are going to face? First constraint will come that your device must connect to a router, right, to get into a wire network. So for that router, what is the major challenge? You need to put SSID and password first thing in your firmware code, right? And in firmware code, major challenge is that once you talk about firmwares, it means they are embedded programs. Once you flash that code or burn that code into the device, and if that device went to the remote locations, if at your home, no problem, right? If your that device is connected to your system multiple times, you can update that code, there is no problem. But once you put your device in someone's home, it means your device is not in your hand. And if you have to update that code, you need to look for some other means. So there could be a case that at your home, once you put up that firmware right inside that device to connect with the router to start sending the data to the cloud, what will happen? The same device that is running that firmware will be deployed in someone else's home. It will stop working. Reason is that now that particular SSID and password is changed. So of course your solution in deployment perspective is not going to work. Development, it's perfectly fine. I'm saying as a developer you will not going to face any problem. But once we talk about in deployment perspective that we face in industry. So first constraint is that in any case, if a new router is going to be installed, you need to take care of your device. So there is one option that you can provide with your IoT device, that you can give it as a your device in Wi-Fi, either it can be hosted in station mode and AP mode. So the first code that you will write in your firmware, you will write, it will work in a station mode. It means automatically your device that is programmed with some static SSID and password, it will try to connect with the router. If that router is not able to get that SSID and password that need to be there for your device, right? Your device must go into the AP mode, access point mode at the same time, and it should advertise some IP address. So what you can do, hard code, you can put some IP address for this like 192.168.1.4, and in that case in your when the the client is getting this device, he will open one particular web page, and from that web page it will enter the new SSID and password, right? And then automatically it will connect, and from that point of view it become plug and play. Anytime if in that home anywhere he will put this device, it will be sending the data to the cloud. Next, either if your client is very dumb, that happens, right? Many times your user doesn't very technical person, so why he will open your web page and all that things, right? People may claim if he is using IoT, so of course he will be very much a little bit techie guy or something, techie nerd. But I don't believe, as an uh, industry, we don't believe, because our solutions should be user friendly. So there are solutions like called firmware over the air updates, and this is one of the demanding skill set in IoT industry, called firmware over the air update. It means once your device has been deployed, right, into the remote locations, it must get connected to the cloud platform, right? So in that cloud platform, you need to think that how this device is going to be connected, right? So first you need to put firmware, and then best way to go with your either if your Wi-Fi is not working, so you should look for two things. You can use easily your cellular based solution. So first, if it will connect with the cellular, it will get the data. It means your device will get connected to that particular platform, and from there you can look out what are the available SSIDs in that particular network, and with that you can from this remote location you can update that code. That is two solution, but this is little bit costly, because you will be looking the devices who should have cellular and Wi-Fi both, and they should be intelligent enough to switch to that device. So the better solution that still people are using in industry is they are like using firmware over their updates. They are not asking anything to do the client, but whenever they give that device, right, they give their device, they generally put like once you buy your router, right, so initially they have one particular IP address 192.168.0.1, either 1 right, and some username and password. So to avoid that security piece, first time that particular credential will be configured at the client location, and then you can take the firmware over there update, and you can update all those credentials, so that security need to be maintained. Because whenever you will put this term on Google universal plug and play, first thing that will come security challenge. Because if someone finds easily your by default username and password, it can easily enter into your network, and one device can destroy your whole home network. So these things are need to be very taken care of while discussing universal plug and play solution. So majorly in IoT section, you need to have Wi-Fi modes. For that you need to understand how to enable firmware over the air update in these devices for the first time, right? So for that I would recommend to use Wi-Fi manager. Wi-Fi manager is a library for expressive that you can use to switch your device from station mode to AP mode if that same router is not there. And then once that new SSID and password will be configured with that device, automatically your device will get connected to the cloud, and it will again go into the station mode. And then whatever new functionality you want to add, you can use it using firmware over the air update. And in open source, if I talk about, you have a platform called m-.net. M-dash basically on the top of your Arduino IDE uses Mongoose OS wrapper that helps you to easily provide the solution of this firmware over their update. So you can use m-.net for FOTA and all, and around 10 devices initially. If you are not using commercial and you want to go for some testing purpose and all, 10 devices are free to connect. You don't have to pay any amount. So let me show those things, how those things basically works in the actual deployment perspective. What are the IoT platform, how they are, you are going to check that they support HTTP, they support COAP or not. So I'll discussing in next half an hour those practical scenarios. So before that, I'll love to hear from you. If you have any doubt into it, you can ask your query, and then I'll move to the actual development perspective, how you can deal with these things. Either we can keep the doubt session in last. Both the options we are open, right? So this is very basic of your HTTP COAP and your plug and play solutions, right? So let me go one by one. So there is a platform called Thingsboard. This is open source IoT platform. Okay, for IoT protocols, actually, there is one important, not simulation, but Node-RED is one important platform. With that, you can use actually your prototyping or solution without writing lot of programs. This is very fantastic solutions. Once if you are not very good with the programming and you want to use COAP, MQTT, connect your data to the cloud, databases, everything you can use with this Node-RED, right? So this is from IBM and it is again open source. So generally in industry, we people use this platform for showcasing our initial POC to the clients without device. So here you can easily even writing without any program, you can control your devices and all, right? So this was the question from someone that how we can use these for simulation, and also easily you can use, you can create dashboards and all without cloud also. So in second half, once I will be discussing MQTT, I'll give you a little bit flavor of this Node-RED, how you can use this Node-RED. So before that, let me go with this platform, open source IoT platform. So in the whole, my talk for the day, I will be relying only open source, because I believe open source is one of the best things, that is available for educational community as well as for any beginner to understand the concept and, enable the test bed or proof of concepts. So Thingsboard is one of the best IoT open source platform that you can use for creating your solution, connecting your devices. So if we study like HTTP and COAP, so first we need to understand that if my device need to be connected with the cloud platform, it must support the extensions or connectors should be there, right? So if I go into their documentations, right, documentation side. So here, if you will look at that particular site, what are the things that they have available, right? So here, if you talk about platform integration, they have HTTP protocol. It means easily you can use HTTP protocol for sending your data from device to cloud. You have MQTT protocol. Then more important, OPC UA, right? I hope some of you might have done some work on OPC UA. Now SCADA based systems are getting replaced with OPC UA, right? OPC UA is one of the fantastic protocols for industrial IoT. So people are using with PLCs and all with OPC UA protocol. Then you have HTTP MQTT, and then you have COAP protocol also, right? COAP implementation is also there. So if I will go into the integrations, you have HTTP, MQTT, all these things are given, but COAP is also there, right? So let me show you that particular part. So these are two things that is very important. Once I discuss about this IoT platform, it has two versions. One is professional edition, one is community edition. So professional edition, of course, have their support system. If you are working in an industry and you get stuck somewhere, so their team actually help you out to understand the problems, and more features are there, like email plugins and everything is there here. A remote procedure calls, you can easily update your device from any particular place. So let's see that how you can use your HTTP protocol here, right? So if I go into their guide section, right, so they have given lot of important data here. So what are the features that are available here? See, so in their hardware samples, they have ESP32 OTA things board. It means suppose you have a ESP32 device. This device, I don't know is it visible or not. This is very from Espressif. This is very powerful device having Bluetooth and Wi-Fi uh, radios. So this is the device that I'm talking about, ESP32, right? From Espressif, right? So this is very fantastic low cost and low power device, having now even low power solutions. You can also integrate it, support deep sleep modes and all. So this is very good board, and it comes with lot of variants. So I, as a beginner, if anyone is beginner, even AIoT, artificial intelligence based solutions, you can also run on these devices. So they have now multiple variants of these devices like Solo, Roam, Rover, and they have, if you will go into that, you will find their flash is, in multiple variants. It is available 4, 8, 16. Like for example, if you have to go through these devices, so you can find it out. This is dual core device, right? And they have support of protocols that you seen yesterday, UART, SPI, I2C. It means wired communication you can also perform. Like some microcontroller you have, where you have, implemented your sensors, and those sensors you have integrated in those microcontroller, and they doesn't have any, capability of transferring the data to the cloud. So then you can use wired based communication to your this ESP32, and then you can extend your data using Wi-Fi mode. So these are a lot of variants. So PS RAMs are also available in some variants like Rover series, right? And they have flash RAM in multiple variants, 4, 8, 16. So this port is very easy to start in IoT. If you are like want to develop your quick prototyping, you can easily use ESP32, and lot of documentations and sample codes are available over the multiple communities. So easily you can find sample codes even from Espressif. It is also available, lot of sample codes, integration of those sensors. So you can find it, buy these boards if you want for practice. Though again, I am not the brand ambassador for this. Just I am giving the suggestion. It's so easy as compared to any other board that available in the market for like your developing solution also. And it is very less costly. 650 or 700 rupees is the cost of this board, having Bluetooth and Wi-Fi, right? While if you will move for TI CC3200, and they are costly. So you can easily program your, these devices either using Espressif ID, that is official ID available from Espressif. Either you can use Arduino ID, right? So Arduino ID has all the libraries to integrate these sensors. So you can use these particular IDs also, and then in that you can use MQTT SDK, HTTP SDK, all those things to connect to the IoT platform directly with these devices without having the need of gateway. If you are not looking for edge computing or fog computing, looking for downsampling of the data, are more concerned about HIPAA compliance and all, if you are working in your healthcare industry, so you can directly send the data to your cloud platform using these devices. So coming to the things board, see there are a lot of sample examples are given, like ESP32 PicoKit GPIO control and DHT2 sensor monitor using things board and Arduino SDK, right? So easily you can use these particular ESP32 based devices, and you can check some sample examples are given. So like here, if you talk about very fantastic documentation is from there. If you are beginner, you just read it properly and you will find everything from connection, from connecting your device, how you can add your device on this platform, and then these access token, how to generate those access token, how to enable your ESP32 device in your Arduino board, because by default Arduino board doesn't have ESP32 based packages. Of course you need to enable these packages. In that case you can use this particular platform to enable these things, right? And then see here, Arduino HTTP client, it means they are going to use HTTP protocol for communicating your device to the cloud platform, right? So this is very sample code that is available, and later you can practice these codes, and if you stack some pair, I have put up my email ID also. I'll help you out if small errors and all you are getting later on also. So access point and Wi-Fi password, right? So this very sample code, it is available. This is nothing but a boilerplating, or you can say it's just a template that is available, you can easily use. So these are like nothing but your LED numbers that you want to control, right? And these things is nothing but your boilerplating. You just need to change some small thing, that's it, right? So these are the sample code that are available, and if you are familiar with the C programming and all, you can easily use, and you can perform HTTP based operations using this. And why I am encouraging you people to use this open source platform, because you will get a very clear understanding. For example, if you want to use MQTT, so MQTT is the second session that we are going to discuss. So technicality you will understand, and then sample codes you can use from here to develop your application. If you are very much interested to go for cellular communication, you have SIM 808 module that you can use for developing this application. If you want to use ESP8266 port, this is like before ESP32, ESP8266 was there, that you was having only Wi-Fi capability. Then you also have the sample codes and demonstration video, right? So it will enable you to do your coding by your own self, right? Then a lot of things are given here, like for Raspberry Pi it is also given, right? So bare metal boards is also given there, and Wi-Fi boards are also given there. So let me give you a very basic hint how you can, without device, you can practice sending your data to the cloud platform. So first perspective is these are the sample codes that later you can practice once you have these devices to understand how your IoT ecosystem works. But first thing is that how to start with this IoT platform, right? So the basic thing that you need first to create your account on it, right? So if you will go on this, so you can use demo things board sign up page, right? So here it will ask you to create a particular account on it. So a more important thing is that you can also install this platform in your own premises, because this is open source, right? So if you don't want to use this cloud platform, if you want to test it, you can deploy this whole cloud platform in your location, right? So this platform you need to create an account. So if you are interested, you can easily create an account here using this demo.thingsport.io sign up page. So I am directly signing in on this platform because I have already account on this. So this will prompt me to the login page, right? And if this particular account is already logged in, so it will directly make me to internals of this particular Thingsboard platform. So in this Thingsboard platform, there are a lot of features, like you can create dashboards. You can easily create your multiple devices. You can easily use your remote plugins for like sending emails if there is any anomaly, or if data is going beyond certain threshold. All these features are available in this platform. Seems little bit slow today, this platform, but you will get these options for your creating this particular platform. So here you can put your first name, last name, email, password, and then either if you don't want to go with this, you have option of sign up with Google, sign up either with Facebook, or sign up with GitHub, right? So once you will create this platform, you will get an URL on your email ID. From there you can log in on this platform easily, and once you will logged in, you will get this particular page. So say like I want to log in on this platform, right? So I will enter my email ID and password. Okay. So if you are going parallel, you can create account, right? For the time being, easily you can create. So let me reset my link for a second, and then Right. So see, once I have reset my password, it is now making us to go on my this IoT platform, right? So there are multiple things given like customer management is there, asset management is there, entity view management, device profile, devices. Device profile has just recently added in 2-3 days before. Audit logs, dashboard, widget library. So you can explore these things later, like customer management, how you can allocate your devices to the multiple customer, like uh, I have created certain customer, right? Different customers. So customer means like for example you have multiple clients, right? So you can assign your devices to those customers. So first thing, once you will go, you will find that how you want to communicate your IoT device to the cloud platform. Your device could be anything. Your Linux based device could be like Raspberry Pi. If your bare metal could be ESP32, ESP8266, right? The first step that is required for this is once you log in on this platform, it's open source, right? So it will not ask any money or anything. Open source means you can get the source code of this also, right? On GitHub it is there. So in devices section, first step is you must create a device, right? So if I click here, so it will ask me to add new device and it will pop up this particular window. So here I am creating my virtual IoT device. So many times you have heard about this term representing our physical devices into the virtual devices is called IoT. Many places people use this terminology. So this is nothing but a virtual device that you are creating. So here you need to write name. Say like I want to write name, for example Linux device, because I am not going to use any particular device right now. I want to just use my Linux system to send some dummy data to this uh, particular platform, so that we can understand that how this particular IoT ecosystem works, right? Later we can interface sensors and we can send some real-time data. Label like label 2, label 3, so you can leave it also. Either you want to write any label, write say Linux device Ubuntu, right? So this become your label for this. Just it is you can say metadata for this. Transport type you can select like MQTT or default. So let us go with default, whatever we wish to we will use, right? And device profile, let us go with default for the time being. I don't want to create any device, and I will device profile, and just I will give the description. So description I want to say like post data from Ubuntu system to things board using HTTP, hi, HTTP protocol, using HTTP protocol. And once you will click on this next page, it will throw you credential, add credential, right? So add credential means every device requires some uh, crucial identity, because if there will be no identity, how they will manage the data, right? So it means there are 100 devices, so there will be 100 specific tokens. So this is called access token. So here credential type you have access token. If you are going for non-secure communication, so either you have like these particular methods also. So access token you can create here, and it should be like maximum 20 digit, right? So say I'm taking like IIT GOA FTP, right? FTP 2020. This is my access token. IIT GOA FTP 2020. I will copy it because further it will require, right? So my device is created. Here you can see. Name is Linux device, device profile is default, label is Ubuntu, right? And I have not allocated this device to any customer. So my device is created and my data will come into the sorry, let me go a little bit slow. So if I will click on this particular tray, so it will open this window. So here you will get the details of your device. These are server attributes, latest telemetry. Here whatever data you will send from IoT devices, you will see your data here. Here you can configure your alarms and all, some relations. If there are outbound relation, inbound relations you can create, and audit logs data and all related logs you will get here. Say here like credential updated, devices added. So whatever I am doing I will see here, like audit whatever we are doing on this particular ecosystem in these devices. I will get the audit log related to this device. So how to get started, right? So the very basic things some of you might have practiced also. There is a curl command. With curl command, server people, like someone who is might have working in the server domains and all, so you use curl command for posting some data, like you fetch some CPU, CPU load, and you are sending data to the cloud platforms. All those things you can use curl command, right? And there is someone has raised hand. Yes, do we have any question? There is no retention policy, right? And till now they have not updated any retention policy, so it will keep your data till this platform will exist, right? Now it's not like 30 days, 20 days, right? So it will keep your data there. But basically important thing on this platform is it is streaming platform, right? So it will not store your data in any database and all, because it's not like open source, so they do not put lot of uh, load on this. But in professional edition you have you can download your data in Excel sheet and everything, right? But in community edition you don't have, like you can download your data in Excel sheet and all. Either you can download your data in .sql file. Those things are available, but that is available in professional edition if you want, like for making it in the persistent data storage, right? So that thing you can do. So there is one question: is there any device available that helps to resolve heterogeneity issue when integrating different network? Different network together. See, when we talk about heterogeneity, it means one device that is coming from particle boron, but it is very costly, around 9,000. They have around most of the uh, radios available, right? So you can look out particle boron, but it is around 9,000 something is the cost. So I don't believe that will be very uh, customer friendly, but for POC and all you can check it out for that. So coming to this, how we are now going to send this data on this particular platform, right? So if you will go on their REST APIs things board, if you will put there, they have given you some sample example right here. One is Swagger, that is available, that is not more important for this. Here you can see Thingsboard API reference, right? This is available in your docs API section. Okay. So here MQTT, COAP and HTTP API is given. It means we have studied COAP and HTTP. So we can see how we can send these data to the platforms, IoT platform practically, right? So let us go with first with HTTP API, right? So data is JSON format, key value pair, right? So here some examples are given. I was talking about post methods, right? So you can see here like given curl -v -x post -distance for data, and this is file telemetry data as object.json .json notification file, and this is localhost.8080 if you have installed this platform on your system, might be on an Linux system, right? Then easily you can use this particular URL, right? Then you have this particular API /v1 $, etc. This is your resource path, and then header content type application /json. It means your data format is going to be the JSON format, right? So let us try with this command and check that is it working or not with this device, right? So let me create one particular file here. So 1 minute, give me a minute, let me open my terminal. Okay, so okay, so let me first create a JSON file of some dummy data, say like sensor data .json. Later you can extend these application with the sensors also, that is not very big deal. So if I comment this line, okay, so let me first create one particular JSON format. Say like I want to create JSON format is key value pair only, right? And it is again similar if you have practiced. So place, say I am writing Pune, okay, and orbital, let us take it IIT Goa, okay, and then comma, and then you can write like sensor name. Say sensor name could be your TST22, right? It is sending two values, temperature and humidity. So I will take temperature here first, temperature say like 20, right? And then we have to take one more value, say humidity, right? So I'll took humidity first, humidity. So two values I got, right? And then humidity say I taken say 76, right? And then device name, if you want to put, you can keep it like say for dummy device name we can take like say Raspberry Pi, right? Because Raspberry Pi also support Linux environment. So here comma will be there, and then you can put your close your curly braces. So let me first so here what need to be changed? First, telemetry data object.json file. So I have created sensor data, right? So we have to change this particular name, sensor data.json, right? Then again this particular URL will change, because that URL that we are using is demo.thingsboard.io, right? Then API slash v1 and access token need to be changed, right? So that access token we need to check from here, right? So if I will go in details and manage credentials section, I will find the access token. I'll copy the access token from here. It is in manage credentials section, right? So I'll copy the access token here. Telemetry header, everything is fine. It means now my command is ready for posting the data curl, right? So I'll copy this command and okay, so it is, you can see here it is coming like HTTP 1.1 200. It means this is success, right? So let us see data has came here or not. You can see whatever data that I sent here using HTTP, my data is able to reach to the cloud platform, right? So very simple, you can use this HTTP with Raspberry Pi, writing your Python code or anything, right? Very simple, just you need to change this particular thing with the uh, you know uh, exact some APIs will be there from the sensors, and those sensors you can integrate easily and send the data. So let me give you one more example of Python. How can you use Python to send this data? So this we have just use curl command for posting the data. But how we can use Python implementation? For example, in Raspberry Pi tomorrow, you are interested to work with the Raspberry Pi board, and where you integrated some DHT22 sensor, you want live data. So you cannot use these curl commands and all. It is good for like you can also use this command, but little bit reverse engineering will be required. So best is to go by Python, either Node.js based platform. So for that I have written very basic code snippet. Let us try it out that it works or not. So it's very simple. You will find that 2-3 lines of code are enough for your So same this command that I have written, you can write in Python also. Just you need to, there is something called in Python OS module, right? OS module. Same command you can use. OS module is there. So os.system will help you to, run it like multiple times if you want. So here you can write data.json file is there. It is getting the data from that, and same application slash JSON. Then you want to print and you want to increase the count, how much time your data is printed, right? And then uh, you can send the data directly. This is one option you can use in Python script, writing with your Python script, right? Same command you can use in the Python. So whatever command you run on the bash, in Python you can use os.system, and inside that copy the same command, it will work. Now this is for ThinkSpeak platform. I will also give you the hint how you can use ThinkSpeak, and also ThinkSpeak also support your MQTT and HTTP that you can use. So similar way you can use these things. Let me now come to the how you can use your things board with Python request module, right? So for example, you want to use your things board in the Python, right? So the last example I was showing that you can use curl commands inside Python also using os.system module, right? So let us understand how we can write same program in Python. So in Python we have some module called request. So I was discussing yesterday about these modules, right? And one is JSON. JSON is basically used, for the JSON format, sending the data in JSON format. So here, if you see, there is an API called post. Similar to that, you have get API. Post means you want to send some data to the cloud platform. You want to generate. So the first argument it takes is what? Your URL, full URL. So here your API v1 slash this place, what you will write now? One minute. Here first thing is your URL API v1, and this is your access token, right? So access token you can replace here. What was the access token? Let me check again. So you can go in manage credential and you can copy this access token, right? So here you need to put this access token, right? And telemetry. Next is data is equal to json.dumps. Json.dumps is basically used to convert your dictionary into JSON format. So here I have taken temperature 22, humidity 78 in the dictionary format, and json.dumps the function will convert this data into the JSON format. That's it. And comma headers, content type application slash JSON. And then you want to print your status code. And then after this, suppose you want this particular operation perform multiple times updating the data. So yesterday I was telling you can use time module, and you can use time dot sleep, right? Time dot sleep, and you can give 2-second delay or might be 5-second delay, right? So with this you will be able to understand that. So say I am giving here while true, continuously run this, right? And then so 5-second delay, right? So in place of this, if you are using any particular sensor, so yesterday I told how you can use. So from this temperature and humidity, in place of this you will write the API that will be giving you the data on this, and then same code will run. 3 lines of code is will be able to send your data from Raspberry Pi to the cloud platform. It is so easy, just we need to understand the concept. So let me try this code. Okay, so Python 3, and then let me go with this. Okay, so it is saying 200. It means my code is successful. So let us see that this data is coming or not. So here, how will you able to distinguish latest time stamp 11:30:44? You see that after 5 seconds this data will be getting updated, right? 55 temperature 28, humidity 78 we are getting here. So this is the real time data that is continuously coming from my device after every 5 seconds. And the best thing is that you can create easily dashboards also here. Just click on this, click on show on widgets, and you can create dashboard. So it's a very easy platform for getting started in IoT domain, right? So if I want to create this way, you can use card, date, digital gauge. Suppose I want to use digital gauge, right, for this particular data. So we have various ways to represent this data to see on these platforms. So these are the nothing but not real time data. This is dummy data, but this data is coming in real time, right? Because this is the streaming data. So you can use this kind of multiple ways to reflect your data what way you want to. These are digital gauges that are available. You have also available analog gauge that you can use. You have maps also. So there are multiple things that are available you can use. Analog gauge is also available for this, right? Like this temperature if you want. So if you will add to say dashboard, you can change these units and everything, right? That we will be discussing also in coming. So you can create new dashboard. Say I want to give like IIT GOA FDP, right? And if I will go here, I will add this. I will be able to see my data that is coming from that particular place, right? This way. You can edit this. You can make it as large as you want. And so this is the way IoT ecosystem works. This is a very common example where you are seeing your data from devices coming to the cloud platform where you are able to visualize your data. So this is one HTTP. This way you can use same. You have also the COAP API that you can use, right? Just for example, if you have to use COAP, so you have to just do some little bit changes here. Same, so you have to use cat command and then you have to use the pipe to post this data. So just you need to do little bit changes here. COAP colon demo.thingsboard.io and you put access API to access token here and it will work. Telemetry data object.json is nothing but that JSON file I have created, right? So this way you can use COAP protocol also to send your data if you want to create your basic particular POC concept, or if you want to give anyone the working principle and all. And you can in the backend side how those access tokens and all working, you can use Wireshark tools and all to analyze this protocol much in detail. So this is very basic of your COAP and HTTP that you can get started. Later you can use for anomaly detections and other things you can integrate in your just implementing your programming logic, right? So this way your protocol generally works. So now this session is almost I think over. So we will cover other aspect also like MQTT and all in coming session. So now I think if questions are there, we can take questions.
So there is one question which is this data is not continuous. So
Okay.
how to do that? I mean, if you have continuous data
So I
streaming.
think that I made it in the next script. I think this question was curl command was not like continuous data, but this data is now coming continuously because I have put up 5-second delay. So if we'll go into the devices section and in devices, if we'll go latest telemetry, right? So you can see this is continuous data, continuously changing. You see the time stamp. It's 11:35 now. It's changed to 12, right? It will change continuously. You can see this is updated data, right? Because this is dummy data, so value is not changing. Once it will be sensor, so if your temperature will be increase and decrease, so your of course the value will change. I'll give you more clear perspective in the last session while we will be using the real time with these Raspberry Pi boards and sensors, right? So you will get the how to use these APIs and all for real time.
So the dictionary will get updated if you have a real
Correct, correct.
sensor that's working. Okay. There's another question from development point of view. Which one will be better, Contiki Kuja or ThinkSpot?
So see, Quantiki Kuja are simulators, right? Where you can, in Kuja you can simulate how your data is traveling through multiple path and all. But like for research perspective, Quantiki and Kuja is good. For like industrial perspective, of course, ThinkSboard will get the advantage over Quantiki and Kuja. So that is simulator, and these are the actual deployment that happens in industry. You are getting the real-time data from the sensors, and you are acting based on that data. You want to switch off something or something. All these things you can do with this.
The next question is, if I want to use my RPi board as server and post my data over it, then can it be done?
Yes, of course you can do that. You just need to, create one HTTP server. So you have various options I was discussing. Either if you want to create from, Python side, you can use Flask and either Django with Plotly. So you will get these kind of API there, right? And you can use some other device if you want to like ESP32 as a client device from your sensor attached. So with that API putting in your ESP32 device, you can send data on your Raspberry Pi. So Raspberry Pi will act as a local IoT platform, and then from your ESP32 you can send the data. If you want to use other platform for like Node.js and all, you can use Mean Stack or Man Stack. Of course you can do that. In PHP you have LAMP stack, right? You can also use that, more easy LAMP stack, Linux, Apache, and then PHP.
Next is, can we create cluster plot? So yes, I mean, you have to see what options there are in terms of plotting in
Yes,
the.
you can do that. You have graphs, multiple clustering and all, you can do that.
Next question is, hardware software co-design any IoT model available, whether the same thinker board will support.
Hardware support co-design any IoT model. See, anything if you talk about even this platform, these are hardware and software. Both the things are, because in IoT without combining those things, you cannot even think about IoT, right? So these things are nothing but your hardware, software, co-design IoT model. Like things, any IoT platform you talk about, you need to write certain code, right? Then your hardwares are getting integrated with these platforms. So of course, these things are available. Multiple, even AWS IoT, you talk about Google IoT, ThinkSboard, Thinger.io, IBM Watson, all these platforms are this only hardware, software, co-design model only. So there is a question for medical IoT. See, in my perspective, I currently working in healthcare domain only. IoT concept always remain the same. Your device sensors are going to be changed, nothing else, right? Either your might be you are thinking for like at the end device you want to use Bluetooth. So of course you need to understand the Bluetooth terminologies, gate profile, gap profiles. If you want to use 6LoWPAN, right? So for 6LoWPAN you need to understand 2.4 gigahertz, how 6LoWPAN architecture works, how 6LoWPAN stack is going to be supported for if you on the top of you are using BLE stack. It means some constraint on the header size somewhere. Many times you will find that defragmentation, fragmentation, many things come into the action. So just on the top of that, connecting to the cloud, these protocols are going to work. Just at the lower side you need to read it out, what context you are looking for, whether you are looking for Bluetooth low energy, whether you are looking for 6LoWPAN, whether you are looking for Zigbee, whether you are looking for thread. There are various MyUI, LiveFi. So depending on the need, you need to just change that particular thing and change the sensor, you will get the data. That's it. So concept will remain the same.
So if there are any books or any resources which talk about specifically about medical IoT, so when you send me the slides, perhaps you can include something there. If there is any such book or
Yes.
website, or some
See my
companies which work on medical IoT, so their white papers or
right,
their
right.
resource library can be referred to.
That sure I'll share.
Yeah. So we'll just take one last question and then we'll end this session. So which platform is better, IBM Watson IoT platform or ThinkSboard?
See, ThinkSboard is open source, right? So for me, what I would suggest open source. From IBM Watson, of course, your costing will be more, right? Feature wise, IBM and your ThinkSboard having almost same capability. Even ThinkSboard has some rich capabilities also. But of course, they are big vendors, so they are getting more names than ThinkSboard. The major reason is that these are very small companies, but they are open source. So people doesn't put these attention, and they don't put lot of time to our effort to get these things. But ThinkSport, Thinger.io, and your Kane, there are a lot of platforms that people have not explored. Let me give you one more example of COAP platform. This is again very fantastic platform, but little bit more it requires, right? This is also very good platform. So you can explore lot of open source platform rather than directly going to the uh, AWS IoT, because you need to pay lot of huge cost for that. So better start with these platforms. And if you think that your huge comparison like 10,000 devices if you are deploying, right, then you can think about cost perspective, then only you can decide which one is better, which one not. But costing ThinkSport is less than the one that IBM or AWS IoT charge for this.
Okay, so thank you, Mr. Bhupendra, for this nice session. And I can see from response and interest that people really liked it, which is very good. Especially the hands-on thing is something that that is also a focus of this FDP. So it's very nice. So on behalf of everyone, I'll thank you, Mr. Bhupendra, and we will close this session. We will start with the next session at 12. So we have a 15-20 minute break. And please use the link for the second session that has been sent to you to join the second session. For your attendance, I am giving you the link. You can mark your attendance on the link that I have just shared in the chat. Okay. So thanks everyone. Take care. Take a short break. We'll meet up again at 12, around 12. Okay.
Okay.
Yeah.
Thank you.